Greetings. Thank you for joining me today. Those who have been watching me a while may have seen my earlier video, and I'll post a link, my earlier video where I looked at an under the sink water heater where it had failed basically, and I was looking at why it had failed and repairing the issue. Now the under the sink water heater failed because it was sitting on a flat surface and a leak from somewhere puddled underneath the water heater and started acting on the steel terminals that connected to the heating element. And eventually the corrosion got so bad that the terminals, the power wires, just literally fell off the heating element. That caused an electric shock hazard, of course, and stopped the water heater working altogether. Now, I should have checked it earlier, and I recommend that if anybody has that sort of system going on, that you check it regularly for leaks. I didn't, my failing. I was lucky that nothing bad happened. It didn't even trip the RCD. However, moving on from this, I fixed it and put that thing aside for later use and vowed to make sure that the next build would be a safer build, in that I wouldn't allow water to build up underneath the heater under any circumstance, just in case a leak happened again. I've got cats fighting in the background. Well, so to that end, the new build we've got, the new water heater, is an above the sink water heater. It's better by design because whilst it's, some would say, an eyesore in sight above the sink, if it does develop a leak, you can see it happen, and the unit won't ever sit in a puddle. It certainly won't sit in a puddle of its own making or from anywhere else. It's sitting on the wall, which is kind of useful in that respect. You still do have to make sure it's thoroughly checked so it's not an electric shock hazard, but still, you know, you can see problems as they develop. Well, I'd fixed the old heater and put it aside ready for the next project, and I vowed on the next project that it would be used in a way where the water couldn't build up. So I decided to use it in the bathroom kitchen sink. In the bathroom sink, and I made a cabinet where the space for the water heater had lots of holes drilled, basically. So it's designed to sit on the wall, basically. You can see the unibody design allows for above or below the sink mounting, and you sit on these hooks. You can sit it flat on a surface, don't do that. But the new design had it sitting on hooks, and just below, to stop the water building up, I drilled lots of holes, so as and when it failed, and it did fail, as and when it failed, you'd see the water just leaving the unit. You'd know what the failure was, and we could establish whether the failure was the water heater itself or some other part of the system. So in my new build, and I'm going to put in a picture or two about here, I think, in the new build, you've got a distinct area for the heater, a distinct area for the sink, the taps, and a distinct area for the supply to the bidet mixer. So it's all in one space, but every area of that build has its own space and its way of demonstrating that it's failed as and when it fails. It's good for root source analysis. Well, today's video we're going to have a little look at why it failed again. Yesterday I was out shopping when my youngest, he took the unprecedented step of texting me and then phoning me. Youngsters these days don't tend to phone you much, do they? But he phoned me on the video, which is taking it a step further than literal telephone call, and all I saw was a flooded bathroom. Yeah, there's a flood, Dad. I think it's coming from underneath the bathroom sink. And he showed me where it was, and he knew exactly what had happened, or what I think has happened. So yeah, water was pouring out from underneath the unit, but it wasn't building up, and that's a good thing. Now, I fixed it and pressed it back into service, and when I applied the water pressure to the whole system, I could hear a creaking going on. Now, I put safeguards in place within the new build, so an expansion chamber, and I was aiming to get a pressure relief valve as well. I hadn't got around to that bit yet, but it was by the by. I don't think that would have saved it, because the pressure relief valve sure didn't save it before, and the pressure relief valve in the initial build, where it was part of the kitchen, was in the actual kitchen tappet, continuous drip. In the more recent build in the kitchen, we've used a different boiler, as I say, and that uses a pressure relief valve and an expansion chamber, just in case the water pressure should go up or down. Now, we've got some building work going on close by, a new estate they're building. And as such, we saw a pressure surge, an unprecedented pressure surge in our water pressure, up from, I can't believe it's that low, to, my goodness, that's going to break some things. And I think a few people in the streets suffered an issue yesterday, and we were one of them. So yeah, it blew out the weakest part of our system. And as I say, when we'd use the tap, you'd hear this thing creak, 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 and I thought, it's only a matter of time before that thing fails. You could hear where the creak was coming from. Now, it's made of plastic, which isn't a problem. It shouldn't be a problem. We have lots of plastic parts in play, the likes of this. These things got a 50-year lifespan on them. Now, my preferred supplier of plastic connection parts for plumbing is the Speed Fit variety. They're available at many local UK DIY centres. I go to Wickes only because they're closest. They've got I don't know if you can see it, a 50-year guarantee on these things. 50-year promise of good service, and it's well founded, because a lot of plastics take an absolute eternity to even show minor signs of degrading. So you can expect it to be probably 50 years before parts like this, pipes like this, pipes like this, or their straight line counterparts will ever start to degrade or perforate. This is a good thing. I just try and design things to last longer than I will. So that's how I approach my plumbing. I don't want to be very elderly and have to deal with this nonsense. And I sure wouldn't need to want to call a plumber out, Why spend the money? Design it right first time. Anyway, so we have these things, and they're great. They're just push fit fittings, frankly. You get an insert, you put it in the pipe, plastic pipe, you push it in, and it works just great. And you can use these with copper piping as well, to create a cracking good little system that is easy to assemble, quick to assemble, doesn't require you to get the brazing torch out, and it will give you a good sturdy result. Those are great plastic parts. The plastic parts under the sink water heater, not so good. And I think what's happened is the thing under pressure has eventually just cracked and failed. It's as simple as that. The sort of plastic we're using in the heater, I think, is closer to what you might see in the average soap bottle, that sort of thing. Anyway, let's turn the camera around and have a look, shall we? Okay, let's give it a shot. So, you may have recalled, you don't have to watch the video if you don't want to, although I do appreciate the views, the likes and subscribes and comments, good or bad. But yeah, you may recall that this thing's held together with these 4 screws. And I changed them out because, of course, the previous screws were rubbish and rusted, which tells you all you need to know about the build quality on this thing. Place those. Hyco. Yes. Can't say I recommend it really. It's good fun though, if you like taking things apart. Something's rolling around, and I suspect it's something I left rolling around in the box, but okay, let's see what went wrong. I'm hoping that I'm on camera right now. Haven't checked, as you can tell. This is just filming and hoping for the best. One moment, please. Okay, so that's all 4 screws out, so hopefully, if I turn this over, if memory serves, it should behave nicely. Now, most of the water drained out when it failed, which, as I say, that points to it failing in the box itself, probably not in these connections on the top, because, well, why else would it have drained completely? Let me just disconnect these spade connectors. Oh, maybe not. Ooh. I'll just put that there, shall I? Whoops. Bit of... marvellous. Okay, so what got wet? Let's have a look. Well, you can tell that it's mostly okay. Now, the device itself appears to have some debris in the bottom, which is to be expected considering how it failed. There's no obvious break in the top here, no moisture lingering around, because you can guarantee if it had been leaking at the top, we'd have seen corrosion on the main contacts here, which are exposed, the initial manufacturer's design exposed and next to a thing liable to leaks. Marvellous. As I say, I don't recommend this thing unless you like trouble. Let's pop that out. I don't think we're pressing this into service again, even if we can fix it. It's too much of a liability. Lord knows, the next time it fails, there might not be anyone around to see the issue. Just like my boy found it when he did. Yeah, oh, hello. Well, the box itself is damp, but then it has been shook around a bit. Where did you... Oh. Oh. Right. Can you see? Probably not. Let me zoom in a bit. Let me zoom in and adjust. Adjust it round. What do we have here? It is literally unscrewed. It's a screw fitting, but it's literally failed here. You can see the stress has literally caused it to completely bulge out. Oh my goodness. Right. Yeah. So, what has happened here? Let me just walk around. You've got to love working with a tripod. You think, oh, it doesn't take up much room. Oh, but it does. Oh, but it does. How well did my potting work? Well, not as well as I'd hoped, as it turns out. Now, to be fair, the potting resin, that didn't do too badly. It's still in place. It didn't run out. I'll put a link to that if I can find it. Manufacturer's website. It is good to sink things in potting resin because it does help. My self-amalgamating tape, yeah, not worth the £8 a roll necessarily, and but it looks like it's washed through a whole bunch of rust, corrosion from somewhere, probably the element itself, and this thing has completely pulled itself apart. Not really. Oh, now you can see here the pressure has built up because this thing is showing stress marks all over, and it's eventually broken itself apart at the screw thread because it had nowhere for the pressure to go. It didn't have any way of relieving the pressure previously, of course, which is why it was designed the way it was designed. But yeah, there's no fixing that, is there? Yeah. Curious design. I guess that's where I'm going to leave it really, because I don't see any reason to fix it. I don't see any way that I can fix it. And frankly, a better solution will be a one of those no storage, no water storage pipes, the on-demand water heaters. That'll be what I'll do. Yeah. But let's just see, for the sake of argument, if I can't grip on this somehow. Now, what I want to do is try and remove some of the connectors here, just to give myself some room to play. I might be able to do it. I think it's going to let me, maybe. No, maybe not. Frustratingly, that whole system should have held. Should have held rather well. Let me just go down the route of dismantling fully, shall we? Now, I can't get a grip on the main thing here to unscrew it properly and screw it back in place. I may be seeing whether it was just that. So, I'm going to get all the other parts removed, and then maybe I'll be able to do it. I'd just love to see if it was actually repairable. I also don't want to leave these components on here because they're worth at least £5 to me, so they're brand new. And who knows when they'll come in useful again, but I'll keep them in stock. This connection, being a plastic one, allows this thing to slip round, which I'm guessing is to spare the unit from leaks. It didn't work though, did it? Because it only built up the pressure elsewhere. My goodness, I've not seen stress marks like that for a while. It really does take a lot of pressure. What happened? Gotta wonder. It was only in a standard water mains pressure, which I know to be quite low, so that points to something going on with the plastic itself, maybe. See, I felt this thing. I'm not turning it hard; it slips around. And this is just a spring fit doodad. Yeah, didn't like that a bit. Right, so they're off. They go into the parts bin. Right, what else? Next, I was trying to get these parts off. The potting resin, of course, is very oily. It makes it very hard to grip anything. I did a good job though. That's the thing, none of my parts fell off. Potting resin's got a funny colour, but I think that's just the rust. But it's spoogy. And the beauty of this stuff is it allows you to do tests on live components by pushing a probe into the gel itself, and then the gel seals up after you pull out the probe, which is excellent. But yeah, I've got no hope have I. Now the oil, of course, stops me gripping things, and it's like minging, and I can't use these teeth. Just kind of grip across it, can I? Can I? Let's see if I can. Oh no, I might be able to. Ah yes. Oh, the bugger's shifting. Pardon my French. Or not. Come on. Some brute force may be required. Yeah, I know. It doesn't help that I'm putting this on a box on the table, does it? But let me just put that out the way. Just resign myself not to be able to pull off these parts. Come on, what's going on here? Unfold that. Try and pull that off. Ooh, that seems like it wants to come off. It does, it does, it does. You will. There we go. That's off. Persuasion. Come on. No, maybe not. Let's persist with this then. This is not what a spanner is for, obviously. But sometimes you use whatever tool falls to hand. I suppose I could also use one of those tools that you use for removing cogs off the bicycle, the chain thing, but I don't happen to have one to hand. Oh, I think that's broken the seal. It's literally popped the thread. Come on, come on, come on, little beastie. So how can you tell me you're busted? There we go. Oh my gosh. Oh well. Oh. So the thing is, this feels like 3mm plastic, and it's very sturdy, so it should be able to take an awful lot of pressure. Mains water pressure, no issue, up to a point. The failure point shouldn't have been this seal. But it's literally done it. It's literally pushed itself apart. This has been the failure point. Now the element itself, it's showing some signs of corrosion, nothing too major. And of course that, I believe, is the temperature probe as well. All just fine. What a shame. What a shame. Because I can't trust this again, not on its own. Not at all. But all in all, a bit interesting. I guess this goes into the recycling. All except the polystyrene, which will not recycle. Apparently it can't be economically recycled. It just ends up cluttering up some formerly beautiful part of Indonesia, I suppose. I don't trust the people in power to make sure it actually gets dealt with properly. Clean up time, clean up time. Clean the bench, remove the screws, remove the evidence, it never happened. Recycle the screws. Yes. Oh, hello, Phineas. Oh, marvellous. And he's busy up on the where he shouldn't be. Phineas. Duh. Well, that's the investigation concluded, I suppose. Sadly, it ends up in the dustbin this time, but sometimes it goes that way. Sometimes it's just not fixable. Whatever you do, anyway, thank you for watching me this far. I hope you have a great rest of the day, and bye for now.